Okay, so just to get yourself familiar with the data here, we just have two polygon data sets. We've got census tracts and we got watersheds, and we're just going to practice really quick. Well, maybe not quick. We're just going to practice doing some GIS operations with some of this data. All right. So any tool that's in here, you can run in the Python window. So sometimes what I like to do is to copy and paste the help, and then modify it to what I want to do. So I don't need to do two unions, so I'm going to do one union. I'm just going to copy that into my ArcPy first example. All right, so what this is going to do is it's going to import ArcPy, which I've actually already done in the, maybe what I'll do, get rid of this whole thing and just do that as a single one there. So I import ArcPy, and then the next thing I do is set an environmental variable. Okay. Now I'm actually going to remove this line for now, and then we'll talk about what it does later. All right. So the first thing that I need to do here is run my union analysis. And what data type is this, by the way? The whole thing. I highlighted the whole thing. What data type is that? Can you guys still see down there? It's a list, right? Now this is okay. This thing right here. It doesn't create a data type at all. So you said tuple, Ashley. This is actually a function. This is a function call, not a tuple. So that parenthesis and that parenthesis are function calls. It is a little bit confusing sometimes that both tuples and function calls use the parentheses symbol. But ArcGIS doesn't really use tuples that much, so maybe just by default set that in the back of your mind. When you see a parenthesis in ArcGIS, it's probably a function call, especially if it's right next to a label like this. So union analysis, this is a function call. What I have highlighted here, does that not show up? Okay. Well, anyway, yeah, on my machine it shows up as purple background. So that purple background area, what is that? What's that? It's a list. It's a list of what? The data type. I'm not asking you to tell me what well above 50 and well above 200 is. What data type are these? Strings. Yes, those are strings. Most of Arc Toolbox, when you run it, most of the time, it's going to ask for strings. Okay. Sometimes it'll be a list of strings. Like in this case, it's actually asking for a list of strings. So ArcGIS didn't create any special classes called layers or anything like that. So most of the time, when you interact with the tools, you're going to be referencing the items that you're going to be using as strings. So let's go back to the union help here and look at what the parameter is so this is how it works. Okay? This is the function that gets called. In the ArcGIS help, squiggly brackets don't mean dictionary. In the ArcGIS help, they mean optional. So there's two required inputs, and then there are 1, 2, 3 optional inputs. So these are the parameters. The first one is an in-feature class. So that's a list of the input feature classes or layers. When the distance between the features is less than the cluster tolerance, blah, blah, blah. But this is what's important right here. A list of the input feature classes. What does union do? What's that tool do in ArcGIS? Sorry, say that again, Ashley.
When you instead of different from an intersect, because it keeps all of the variables even if they're not both present when you're combining them.
Yes, I just figured out how to turn up the volume, so now I can hear you really well. So you probably don't have to talk quite as loud. All right, so yes, that is true. But what do both union and intersect? What's that type of operation called? No. Not really a join. An overlay. It's an overlay operation, exactly. And so these are the list of all the input features in our overlay operation. So we're going to overlay all of the items in there. Now, some functions might not take the same inputs, but this one is. We're going to overlay both of these two data sets, right? And so then, what's the second thing in there? The second thing in there is the output feature class. So in our thing right here, these are the inputs, and this is the output, and these other things are actually optional. So for now, I'm just going to get rid of them because they don't need to be there. Just going to get rid of them. And sometimes the help will actually describe what the defaults are. So yeah, look. Determine which attributes from the input features will be transferred to the output feature class. So the valid strings you can feed it are all, no FID, or only FID. This string right here says this is the default. So the default is to combine all of the attributes. All right, so if I get rid of all the input parameters, all the other parameters, this function takes this list, which is the input files, and then where I want to save them out onto disk, the output files. All right, now if I ran this right now, what do you think would happen if I pressed run on here? What's that? Yeah, it would be an error. What are some of the reasons why I might get an error if I pressed run?
You're running that in Jupyter, but it needs to know where well buffs, all that stuff is, like the actual program in order to actually use it.
Right. But even if I copied and pasted this, because we did talk about this, so even if I copied and pasted this to the Python window in here, analysis, Python, you think I'd still get an error here too, right? What's that?
But it doesn't match the data that you have.
Right, I don't have a data called wellbuff 50. I don't have one called streambuff 200, right? So I got to put in my own data. So if I actually go back, I can start typing, and it'll actually let me do that. Watersheds and sea tracts. Oops, those need to be in quotes. And then I don't want to call my output water buffers. I'll call it watersheds underscore tracts, sea tracts, union. Okay, that's what I'm going to call it. So now I'm ready to run that. I enter twice, it runs, and there's my unioned output. See that? That's my output. If I look at the attribute table, it's exactly as if I ran it from our toolbox. attribute 2.
I don't know if this is possible. Is there any way you could like lower the brightness on your computer? It's like it's so hard to see that on our screen.
Okay.
The orange and the white is.
Did we turn these lights up? Will that fix it?
I don't think, because they get directly what I see. They don't.
Oh, I got you.
Yeah. There is a way. Where is it in here? There's like a dark mode too. You guys remember? Anybody know that where it was?
Did you do it from your laptop?
I don't know if that'll help,
Like
but
when the battery is, you go down the brightness.
I don't think that's what digitally happened. Pretty sure.
does that change anything or no? Okay.
Can you maybe put it on dark mode or night mode?
That's what I'm trying to find. Just a second.
Oh, sorry.
No. Sorry. I'm sorry. I didn't mean to sound like.
You might be able to do that, though.
Application theme. Light,
corner.
dark. Okay. So you gotta save it and restart it here. See if this works. I'm also going to.
If that doesn't work in the bottom right corner, you should have something called nightlight that will also dim like everything.
On the bottom right-hand corner.
Click the little thing to the far right.
This guy?
Yep. Click expand. And then where it says nightlight, click that. And then give it a second, it should adjust it.
Does that change anything?
Yeah.
Yeah, for sure.
I should make it really look a lot cooler too.
For this one.
Maybe it'll be too dark for now. I don't have both of them.
I don't think that's possible. It's awesome.
Yeah. Yeah, it's not,
Oh, so it's looking good for y'all?
it's clear now.
Okay. Rock and roll.
Okay, I lost the. I'm gonna get rid of this window because.
Python.
No, I got rid of the other. Yeah, I got rid of the geoprocessing window since I'm doing it in Python. All right, but I lost the. Well, let's see. Yeah. So this was the command that I ran. Let me put it in. Watersheds. The other one was C tracks. And there wasn't any more. Yeah, and then I named it this. Copy. Yep, and then I enter. Yep, and it's giving me an error now because I'm trying to overwrite a data set that already exists. But maybe now that it's not on, oops. Yeah. So if I want to get rid of that, if I don't want to see this error, it says it can't create it. I can do a few things. I can call it something else, like 2, and run it again.
Now, I'm getting an error on mine, and it's the first time I've run mine.
So did I spell something wrong? Maybe I spelled something wrong. C tracks. By the way, you can press up to run the last command. All right, let's look at the let's look at the data, the catalog view. So under databases, I have my, there's nothing there. Refresh. Cannot create output. I wonder why it's having a problem running it now. All I did was start it and not have it in color.
Maybe just like start the whole thing back over. Delete that one and just go back and do it again. Not too far in front of it.
Yeah,
Did anybody else's run?
yeah. Did anybody else's run? That's been. Is anybody else trying to work along with it?
Mine through Aaron.
See where it saved this. Okay. Oh, that's weird. Now all of a sudden, and anybody else is not working, or is it just mine and Ashley's?
Mine's not working either.
Can't do everything.
Huh.
Oh wait, you're missing the parentheses. Or, well, no, never mind. That was a bracket behind the parentheses. On that. Do you have to put a bracket at the end of it or something?
There's a bracket around here. Yeah. Okay. Okay, is that?
Yes.
What's that?
That's a little bit better for like us being able to see it.
Okay. Can you all still see it down there?
Yes.
Okay. So up here they said it was too dark with the nightlight part on, but okay. I'm not really sure why this isn't working, but let's move on to the next concept and maybe something will work better here. So I'm going to go back into Jupyter and show if we were to run this in Jupyter, it definitely wouldn't work because of what Benjamin mentioned earlier. It doesn't know what watersheds and sea tracks are in this case because we're inside of Jupyter. And so in order to reference those data, we need to actually provide the entire path out. So I put them in C:/temp. I don't know where you put them. So I have to type the entire path to those locations. So I type C:/temp/lab. I don't even remember the full call what? Okay. Just gonna make sure this is still working. Okay. So it's a rather simple way of running it. Okay. So going back to ArcGIS. I'm going to close Model Builder. That was a good question, though. I don't want to save changes. All right. So the part that I deleted at the beginning, now we can explain that. So where's our? I don't want any of this code. Okay. So this is the code that I have. Well, let's say that I don't want to have to enter in this string every single time. Do you see how this is the same as this? Is the same as this, right? That's at the very bottom. Can you see that all right? These bottom parts here?
Yeah.
Okay. So if I don't want to enter that, I have this ability to change things and that are universal to the particular script that I'm running or the particular process that I'm running. And those are what's called the environments. So if I want to go to ArcGIS, I can look up ArcPy environment. So env is, I can change any of these. These are all under arcpy.env, or the environments. I can change things like the ability to add it to the map. By default, it adds the result to the map. But I could change that and say I don't want to add it to the map. I want to say no, don't add it to the map. It's a Boolean, so I'd say false. A lot of these are kind of obscure, so I'll point out the ones that I think are the most important. Well, when you're dealing with rasters, cell size is pretty important. But extent is good. Like if I set the extent, then it'll only process in a certain area. But the one that I want to talk about now is what's called the workspace. So it's all the way down at the bottom. And not the very bottom, but it's towards the bottom. There it is, workspace. So what it does is it honors the current workspace environment settings. So if we set that, the workspace will be a particular directory or geodatabase. So if we set this right here as the second line, we could say arcpy.env.workspace. So we're setting an attribute is equal to, and then we can put the path that we want. Okay. And so now we don't need to put any of this other stuff in there. We can just say watersheds because that's the name of the shapefile or the name of the geodatabase. Oh, I need to close that. There we go. I don't need that line. I don't even really need these R's anymore because there's no more special characters in there. So now what's that?
Isn't that why it was done an error at first? Because they weren't saying where the data came from?
I don't really know because it should be referencing the ones on the map. It can always access the ones on the map. It should be able to. I think that it was more likely that it was not referencing the locations where it was saving them to. So this one. It was no longer, like once I closed it and reopened it, it didn't know where it should save it to. Is it working on yours now?
I'm about to retry it now.
Okay. So it did work on mine now. So it ran and it saved it here. Now I could call this union. Press up. Sorry. Press up and call this union 2. And now I have 2 of the same exact file. And they're all in the database, which is in, I don't even have it actually loaded in here. If I want to put it in, I would have to say, okay, let's add the C, I put it in C temp lab data, and now I can look at it. And so these are the 2 files that I've created, this C-Trax Union and C-Trax Union 2. I've created those 2 using these script tools. And I could also do this here. So I'm going to Control C this and put it into my Jupyter notebook. I'm going to get rid of all of this. Control A, Control V, and I'm going to call this Union 3 and run it one more time. And it ran. Now if I go back to ArcGIS and refresh this, I get a C-Trax Union 3. So I've done it 3 different times. So I can run it outside of ArcGIS, and I can run it inside of ArcGIS. Hey, when you guys press Windows, I don't know if this is on your computer, type Windows and type in IDLE. Or no. Yeah, IDLE. Nothing shows up, right? No.
I get idle Python Jupyter.
You do?
I got idle Python.
Okay. So I don't know for sure whether that's the ArcMap version of Python or the ArcGIS Pro Python, but that's another place you can run Python from if you get that on your computer. Let's see if I can get to it, because I did see it.
It's all capital letters on mine. Well, that matters.
I did see where I could just, like, if I go to C, or no, documents. What happened to my bottom tab? Did I get rid of it? Anyway. Yeah. Go into here. If I right click on this, it does say edit with IDLE. If I right click on a .py file, then it allows me to edit it in here. And sometimes I think it's easier to actually run an ArcGIS script here than it is even in Jupyter. Okay. So you can, if this works on your computers, which I'm not sure if it does or not, you could just run it by doing that. So then I get it right there. Or you could run it at the command line. So I ran that, it worked. And I could copy my Jupyter thing here, and I don't want to save that over it. And I run this again. That's actually going to fail, because if you ever try to run a script that accesses data that's open in another program, it'll fail. So it said it already exists. Right, so I'm just going to call it 4, and it'll run now. And I can go back to Python, or back to ArcGIS Pro. Where'd ArcGIS Pro go? There we go. Refresh this again, and I've run it 4 times now. So there's Union 4. Okay. All right. So save that. So we've run a tool using ArcGIS Pro. So the environment options we did the workspace. The workspace just means what directory you're referring to. There are several that are important. I already mentioned cell size. That's really only important if you're dealing with raster data. If you're dealing with any data and you want to limit the extent of the output, you can change the extent that gets analyzed. And then you can also make it so that it's possible to not overwrite things that they already exist. So here, if I go back to here, right, if I run this again, and I've already said union 2, if I hit enter and enter again, it's just going to overwrite it. That's the default. But if I change that, which I could say arcpy.env.overwrite output equals false. Now if I run that, it will tell me it already exists. But if I go and change false back to true, then it will run it and be happy and content. Now if I try, like I said, if I try to run it from a different program and it's open in a different program, so if it's open in ArcGIS and I try to run it from IDLE or from Jupyter Notebooks, it's going to fail because it can't overwrite something that is open in a different program. Because it's really what it is it's worried that somebody's looking at a data set and somebody else is trying to access that data set and change it. Okay. All right, the last one we're going to talk about today as an environment is, the last thing we're going to talk about in terms of that is describe. Describe allows you to get a description of a particular data set. So I'll do this in Jupyter because it's obvious, it's easiest to see the entire file in Jupyter. So here I could go arcpy.describe. It's another method. There are several methods that aren't tools, but we can describe any data set. So I'm going to describe the output here. By the way, this won't run because it's open in the other data set. So actually, what I'm going to do is put this in a new cell and not try to union it. But I'm just going to describe the watersheds. And run that. Well, that's not very descriptive. I get a geoprocessing describe data object. And I don't know what's in there. So I have to go learn more about this tool. So I'm going to say arcpy describe. And I could go down here, and when I run describe in the help, I give it a value, in other words, a string representing a location on disk, and what it returns back to me is a describe. It's an object that I don't know much about. It's an object. So if I click on it, it will tell me what a describe is. Okay? So a describe has these properties. I can get the base name, I can get the children, I can get the type, I can get the name, I can get the path. So let's get some of these. So if I go back to here, and instead of saying this, I could say path equals, and then I could say path, or sorry, not path. I'm going to call this DESC for describe, and say DESC.path That's one of the attributes that it has. So I have to run this one, and then I'm going to run this one, and see how it gave me the path to that entity. Now there's lots of things that we didn't see, but I can also get things like the fields. Okay, and again, it's telling me that the fields, looks like there's 1, 2, 3, 4, 5, but it's a described field object. So I would need to go read more about what that was in order to get the data from there. But I'll bet if I just said I want the first field, it would allow me to do that. It does. And then if it wanted me to get the name of that field, I could also do that. So that's the name of the first field. How could I change this line to get the name of the third field?
Describe 2.
Yeah, I'd put 2 right here. So now the name of the third field is Huck 8. Okay. Remember, these are the watersheds. I could also, sorry, go ahead.
When you're using ArcPy, is that actually 2 or is that 3? So just start with 0 when it counts?
All sequences start with 0. So this is a sequence. See, the way I can tell it's a sequence when I run it, see how it's putting the bracket here? So it's a list. It's a list of these field objects, but it's still a list. And so I can get to any of its entities by using list notation. And then I just guessed that there was a property called name. I'm going to guess again that there's a property called type. I should go read about it. There is. So there's a property called type. So if I do 0, it should return OID. That's the field type for the first field. The second field, the second field, yeah, is the geometry field. So I could even say for field in dsc.fields print field dot name comma field dot type. See, I'm getting both of the names and the fields, and so I get object ID is an OID, the shape is the geometry field, Huck8 is the string field, shape underscore length is a double, and so on. Shape area is also double. So I've printed each of the data types of every field, or yeah, sorry, the field types of the field of every field, and their names right next to it. So this information is what's contained in. If I go back to ArcGIS Pro, if I open up the attribute table for the watersheds, and then I look at, there's not much real estate here, but see how I have object ID, shape, Huck8, shape length, shape area, and I think I can toggle. If I hit add field, it'll show me that same thing with the field name and the data type. Object ID, geometry, text, double. Object ID, string, double, double. Okay. Close that out. It looks like alias is another one. I don't know if it'll field dot alias. Okay, the attribute alias doesn't exist. So I could go in to describe and look at the describe properties for a field. I don't see the link right off, so I'll just Google arc Pi describe field I described a, what was it that I described? That watersheds. What is watersheds, by the way, in ArcGIS lingo?
Body of water,
What's that?
that's a body of water.
No. But ArcGIS is a data layer, right? It's a data layer in ArcGIS.
The shapefile.
It's a shapefile or a layer. In ArcGIS lingo, it's a feature class. So hit feature class, and then I go to see that I can get, it doesn't look like I can get the fields in there. I don't know where the help is for fields. Maybe it's just under table, because all tables have fields. Let's see. Fields, yep. It's a field object. So I click on here, I click on field, and I can see, I know this is the help for 10.3, but not much has changed with a lot of things. So it's called alias name, not alias. So go back to my Jupyter Notebook. That was already in the same window. And I want to get the alias name there, and I run it. So now it gives me the name of the field type, and the alias name. All these, the alias is named is the same as the name. Usually in file geodatabases, that's the case. In shapefiles, though, sometimes you'll get a different alias because it's because the characters are, the fields are limited to just 10 characters each. All right, so we're getting a little bit, down into the help, kind of like, this is more like a specific type of question, right? But for the lab today, what you're going to do is a very simple analysis where you're going to string a couple of these together. You are actually going to use union. So really all you need to know how to do today is to run a command in ArcGIS. And we'll talk about the lab in a second. But before we talk about the lab, I want to quickly mention the last few things here, is that we've talked about ArcPy as a module today, but there are a bunch of different modules that are for interacting with different types of data. So ArcPy is for interacting with ArcGIS, but there are actually some open source GIS tools that work a lot like ArcPy, but they're free to use. And GDAL is one of them. It's not the only one. There's several others. One's called, let's see if I can, I think one's called Fiona. Shapely is another one. Yeah, GIS with Python. So here's just some helpful guy's written a blog post about using several of these libraries. So these are other libraries that we're not going to get to in this class. I used to teach both the open source and the ArcGIS, but really it's kind of easy to port the concepts over. So we teach the ArcGIS here in this class, but these are tools for doing GIS-like things inside of Python, but there are other libraries. So you have to import. Let's look at the import statement. Yeah, he's importing shapely.geometry, so he's only importing part of the library. You can actually import just part of the library. We can import arcpy.env. So he's importing part of that. He's importing Fiona here, and so on. So here's the user's manual for this, talking about Fiona. So there's plenty of places you can go. So I should probably put GDAL, Shapley, Fiona. There's a couple others actually. One of them's called, there's a more raster one called Rasterio. Did I put that in there? No, I didn't. But that's another one. All right, there's lots of ones for interacting with databases directly rather than interacting with a database through ArcGIS. So depending on your preference or your reason. So PSYCOPG is for interacting with Postgres database, but there's other ones for interacting with other databases at lots of different levels. NumPy is one that we're going to be talking about in this course. NumPy is the module for interacting with arrays. So by default, Python doesn't have the ability to interact with arrays. It has lists and tuples, which are very, very similar to arrays, but it doesn't do arrays without importing what we call NumPy or NumPy, depending on who you talk to. SciPy extends NumPy out and allows you to do scientific analysis of arrays. And the reason I have stars behind these is that they are actually installed with ArcGIS. And so if I go back up here and I was to type in import NumPy, SciPy, this would run. Whereas if I just downloaded Python, that wouldn't run. That's running because ArcGIS installed ArcPy, and it also installed NumPy, and it also installed SciPy. Okay, so it installs a few libraries for you. It also installs this other one called Matplotlib. That's for charting. I'm going to show you a demo of that in just a minute here. It installs Flask. No, sorry, it doesn't install Flask. Flask and Django are web frameworks. So if you want to build websites with Python, you can do it. And Flask and Django, we're not going to do that in this class, but those are Python libraries that will allow you to have Python waiting for incoming web traffic and will allow you to return results of incoming web traffic. And so you can use it to build your web pages. You could also use it to create a web service. And then we've got a few others listed here. Image processing, Pillow is for image processing. Seaborn is built on top of Matplotlib and does advanced statistical plots. Those are all there. These are just some of the ones I've found useful over time. Okay, so in order to show you an example of what these might be able to do, I'm going to open a Jupyter notebook that I've created, and I called it NumPy example right here. So this has some import statements up here that import NumPy, and it imports one sublibrary of Matplotlib, or one submodule of Matplotlib. Okay, and we'll examine this code a little bit more when we start talking about NumPy. But basically, what it does is it uses the ArcPy module to turn a feature class into a complex array. And that complex array has rows and columns of data. And you access the columns of data as if they were a dictionary. See here, I can print just one of the columns, the Huck8 column, and show you all of the values in that array. See if I run this. Take a few seconds to run here. But when this runs, this first print statement right here is evaluated right here. So that's an array. The way I can tell it's an array, it looks kind of like a list, right? See, what makes it look like a list? This.
Those are cool.
Brackets. Well, an array actually looks just like a list when it's printed, but it doesn't have commas. Okay, so that's the way you can tell that it's an array when it gets printed. So, but it's a lot like a list. I could access it by its individual features. So, for example, I could say, are there individual elements? I could say I want just the second item. So 0, 1, 2, it's going to return just this item. See, I'll return just that item. But I want to.
Chart two different.
Yes, I'm getting to that. So, so that was that print statement. Then, what it does is, what this code does is it runs some code to create a chart. So that's where we're going. We're gonna like learn more about these types of things, and then it displays that chart. So here's the chart. So what I did was I took, go back over to ArcPy. I took this shape area field, and I'm feeding the shape area field into its own array, and the watersheds into another array. That's what's going to be all these labels. And then what it's going to do is build a bar chart. So this is the command to build a bar chart, and then I'm adding some labels and whatnot, and I'm showing the result there. Okay. So this is the area of the watersheds in South Mississippi. And you could do something similar in Excel, right? You could create something like this in Excel, but this allows us to do this in an automated fashion. So if we wanted to like spit this out, every day of something, which I know the area of watersheds aren't changing every day, but we had something in our data that was changing every day. We could spit out a new chart and show that somewhere on a website or something. But that's what these modules allow us to do, is to interact with our data in different ways. They're usually for a specific purpose. So matplotlib is for charting, and NumPy is for manipulating arrays. And so we didn't really do a whole lot of array manipulation other than take pieces of it out. We took out just the Huck8 line and just the shape area line. So if I
Would those be using Arc GIS or Arc Pro in some way to show a graphical picture of what you're looking at?
The only thing that I did here in this code that was related to ArcGIS was use the ArcGIS module, the ArcPy module, to convert my watersheds data into an array. That's the only thing that I did in this command. So here's the areas. Okay, let me just print just the entire array. Did I call it array? Yeah. That's the name of the variable. It's not a reserved word. So now I run this. So you see this is the entire array. It's got 1, 2, 3, 4, 5 items in the array, and the items themselves are all of this. They're all tuples. So this is a tuple, this is a tuple, that's a tuple, that's a tuple, and that's a tuple. And the tuples just represent the rows in the feature class. See how if I see these values, those should all look familiar. They're all these values right here. Now the shape itself is a polygon, and it's only returning the centroid of that shape. We'd have to read about that in the help, but this is the object ID right there, 1, 2, 3, 4, 1, 2, 3, 4, 5. I can tell that's the object ID. Then this is the shape. It's returning not the entire shape. Then this is the Huck8. This is the shape length, and this is the shape area, finally, for each row.
So when you say the centroids, we're talking about like centroids like in math, centroids?
Yeah.
Like in statics type centroids?
The centroid of a polygon.
Yeah.
Yep. Yeah, this XY point right here is the centroid of that polygon.
I didn't know you could do all that with this. It's pretty hard to do by hand, so yeah.
Yeah.
That's
Yeah.
really cool now.
Yeah, I mean, you can get it in Python. You could also just get it in ArcGIS. Like, if I wanted to get, I could create a new field over here and just call this centroid and make this a double. Well, I'd have to make two fields to get the X, and well, let's just do the X for now. So I'm going to save this, go back over to watersheds, right click, say calculate geometry, and then I want the centroid X coordinate. Just run that. See how now I've got 603.649.70. 603.649.70. So it's the same. It's the same value there. So that's just GIS has all those functions built into it. It's good at calculating things like that.
Yeah, that's what I was saying. If you try to do it by hand, it would take a while.
It would take a while, yeah.
Some centroids are.
All right, so so that's just an example of something that we could do with some of these. The reason why I showed you with some of these modules. All right, so let's look at yeah. So that's the little stars mean that it's included with ArcGIS. I got to change these links to ArcPro versions, but really, for this week, the only real difference between ArcPro and ArcGIS is that ArcGIS, ArcPro and ArcMap, is that ArcMap runs Python 2, which for this week, the only real difference is you don't have to put print statements, you don't have to put parentheses around the thing you're printing. It's really the only real difference. But I'll change these to ArcGIS Pro links. Okay. All right. So you're going to write two programs this week. Your first, by the way, last week we're just going to do just that program. We're not going to do the other two examples. So this first problem is actually one of the beginnings of last week's, what I was going to have you do last week. So you're going to write a program that reads a list of cities from a file. And then it's going to create and print the contents of a dictionary where the keys are the city names and the values are the locations. So the XY, I totally made that sound not very easy to understand. That's totally messed up here. Let me fix this real quick. This is part of the assignment I just added. So Windows E. Let's go to M4. README. Edit. Okay. Dictionary where the keys are the values, where the keys are the city names and the values are the locations as X, Y. That's what I was trying to say, but I'm going to change it right now because I think it's too confusing. Where the locations, where the keys are the city names and the values are the locations as X, Y, pairs. And I won't specify. You can make them tuples. You could make them. You can make them tuples, or you can make them a list. I don't care. So the values are the XY pairs as tuple or list. Okay. The file location contains a, okay. So let's set this up. So what I'm telling you here is that you don't have to test it on this, but this data right here contains a list, a subsetted list of a bunch of cities, okay? So that file contains a list of a bunch of cities, and this file right here, this location.py, that contains a function that is going to work, okay? And it's going to return. You give it an address, and what does it actually return here? What is this returning? Can you tell?
Can they find the location?
A list.
So it's returning a dictionary, which is fine. You can. I'll actually have it. So you can have it return that as the dictionary if you want. Okay, so it's returning a dictionary with X and Y. So here, I'll show you if I change this to well, here, I'll just do a few of them. So now if I run this, I'll get 3 different addresses. Okay. Three different locations, and it gives me 3 different X and Y's. Right. So this is the location for what? Right. And this is the location for where? Right. Okay. Good. All right. So what you want to do? Let's do this as a. Let's set this up as. I'll set this up as a new Python new notebook. Okay. So this will be the very beginnings, and you can use this notebook to start off. Rayber George _4 _1. This is the one I started creating earlier. I'm going to copy this in here. So now I've got a function. What does this function do?
Is that, so on your location tab, it would be like hard to see where you've got.
Yeah, I got that from location.
Okay.
What does this function do? What is the input? Or when I call this function, what parameters do I give it? How many parameters does it take, this function?
3.
X, Y, and something. X, Y.
No, parameters is your param, right? So.
You're like looking at a variable name. I just chose to call some variable inside my function params. Okay.
Okay.
What's the name of the function? Let's start there. What's the name of this function? Get address location, right? So what do I need to feed it?
Address location.
Candidates and location.
What you need to feed it is data.
Okay, looking at that function, when I asked you for the name, you gave me this, right? You gave me get address location. That's the name.
Okay.
If I were to call that function, what else would I need to provide it? So in other words, if I said get address location, that's calling the function right there. So if I put a parenthesis, sorry, go ahead.
So the next thing would be the list inside of it. Would be a list to go in there.
You just need a name of a city or something. No?
Yeah, I need that some name of a city. Okay. Or I can do a specific location. Yeah. But that's going to go into this address, right? So once it goes into this function, it doesn't really matter how this function works. I'm not asking or requiring you to understand anything that goes on in this function. Okay? You go ahead.
Copy instead of copy and paste like trying to see what it says.
Oh yeah. Well, that's kind of my point, is that it doesn't really matter how this works. I mean, just so that you want, like, what this is doing is it's actually calling a web service. See, if I copy this, Control C, and I Control V this in here, and I say F equals JSON and single address equals 225. Washington. That's the equivalent statement. Press enter. Why did it go to Bing? I just want to enter that. It's okay.
So when you say get address location, you're asking it to provide you what you're looking for? So we can,
Okay. So I want to make this distinction here. Anyway, that's not working, but that's not the point I'm trying to make. Okay. So let me bring this back up here. All right. I want to make the distinction here. When I say get address locations, I'm just calling this function. I'm calling a function. It doesn't. When you ask the question, Elvis, when you say get address location, you're asking it to give you an address location. Yes, but that's because I've written a function that does it, right?
right,
So when I say get address location, I'm calling a function, and it's running this function. And that function is actually going out onto the web. I need to not highlight that. There we go. Control C. Do this in here. Okay, good. All right. So I say question mark F equals JSON and single address. I'm not going to type it all out. Equals all right. So it didn't find any candidates. I don't know why. Let's do Hattiesburg. Still didn't find any candidates. Oh, I don't think I actually need the quotes here. Equals. Anyway, I must not be formulating it exactly correctly, but that's what's going on. Is it's going out to this location and it's feeding them. Oh, it's single line. Sorry, there we go.
is find address and get address the same thing?
There we go. What's that?
Is find address and get address the same thing?
Where does it say find address? Sorry.
I'm just seeing at the top when you get to the window for the web address. They had fan address.
Right.
Is that just a, variable name?
No, this
Or
is an
is it?
actual URL. Like this is a website.
Oh, okay,
This is the website that it is.
okay.
So this website, if you go there, it's a web service. And it doesn't look like your typical web service, but every time I change that single line value, if I change what's there instead of Hattiesburg, if I change this to New York, it's going to give me a bunch of candidates that are in New York. If I changed it to Purvis, MS, it gives me a bunch of locations. Purvis is the top one. It's a program that's running on the web, and it's returning data back to you, and it just so happens that it's data that Python can read, right? It's actually a fairly common way to write website data. This particular format is called JSON, but what does it look like it is when you look at it?
It looks like a spreadsheet from Excel.
Kind of, yeah. But
It's like dictionaries and lists and stuff.
yeah, it looks like dictionaries and lists. It's made up all of dictionaries and lists inside of dictionaries and so on. Okay? That's what it's made up of. Everything in here is either a primary data type, a string or a number, or it's a string or a number that's part of a list, or it's a string of a number that's part of a dictionary. Everything in here is this. So you can read this directly into Python. That's what I've done. So this library right here, this external library, actually it's not an external library, it's an internal library, it's cooked into Python, allows me to make a request to a website and then get a result back from a website. And so I've opened up that website, and I actually read it kind of like I read a file, and I store the results in LOC. So the results of that data coming back are stored in LOC. What is LOC? What is the data type of LOC now?
Location, it was XY coordinates.
It's a dictionary. Yep. See if I print it out. If I print out LOC right here and I run it. Oh, it's address location. I run it. See how it's a dictionary? See that? So LOC is a dictionary.
Which in R Pro will be the attribute table. It automatically lines up attribute table, the database generally you're looking for. It just automatically puts in an attribute table.
Yeah. So this is the first assignment. It doesn't really deal with ArcGIS Pro, but yeah, this is returning a dictionary, and then I'm getting just candidate 0. Candidate 0 is the best candidate. It's the first candidate. And ArcGIS, when we make a request to this web server, it is returning the candidates as a list, and it returns the best one as 0. So it's getting the very first one, and it's getting the location of that. So when I run this, I get the location. Oops, I accidentally deleted the wrong line. There we go. Run. When we run this, we're getting the location. So getting back to the point I was originally trying to make is I explained everything that was going on in that function, but that's not what I was trying to teach. Okay? I was just trying to show you that this function, this this line calls this function, and the function returns a location as a dictionary. That's what this function does. And the point here is not how it's done, although it is interesting, and you could go read now that I've taught it, you can kind of understand what it's doing. Okay, but all you need to know for the assignment is how to call the function. You need to give it a string that represents a location, and then what you get in back is your dictionary location. So you could say, you know, Hattiesburg. I'll just call this my location equals that. So now you can print my location. And you get that location. All right. So what do we need to do? Sorry, go ahead.
Did you run that print location? Did you run it?
Yeah, I ran it. That's what printed right here.
Oh, okay.
All right. So rather than do this, what we actually want to do is read the file line by line and then feed that line into the function. So that's what we need to do. We need to read the file line by line. All right, so remember last week we did that? Well, since I didn't formally do that, we'll introduce that concept again. So we're going to open up a file and read it line by line. So there's all sorts of places people have done this on the internet. Read a file line by line in Python. Don't even know if this is a, yeah, so that's going to work. All right, so path to file.txt. Where's my file? Well, I have to go find it on disk. I put mine in that M4 folder, and it's this file right here, the cities subset. I need the full path though. All right, and then if I want to read it line by line, it's just for line in FP, which is the file name. It's just a variable. Print line FP dot close. So by the way, what is FP? Here. Is it a string? Is it a... No, it's none of those. What is it? Using what we've talked about today. What's that? Yeah. It turns it becomes a class. So we're opening it, and the result is a class, and we can close it. Print.
So that is pretty much a class dot method.
Yep. Yep. So FP is technically a FP is technically an object. It's an instance of class file. I don't know if that's the exact name of the class, but it is. Yeah.
Right there where you have open, I want to make that instead of pulling from C, I'm just pulling directly from MapPossum. I'll just put in the URL there.
What's MapPossum?
Your site for
Your
the
site
class.
Oh.
where you have top. Go put the URL in there and pull it directly from that location instead of pulling it from my local. Because I'm thinking like when we turn this in, if it pulls from them, pulls from the server, as long as you have internet, then the file works. But if it pulls from our local drive, if we have it in a different location, the file won't work.
Yeah. So you would have to use a library like URL lib
Okay.
to do that. Okay. And yeah, you could go look. So if you go to the website itself, and you click on this button, location.py, right? That's the one. No, it's this one. Okay. And then, yeah. See, if you requested this URL, you're actually going to get everything that's on here. You see it? You're going to get Learn Git and GitHub without any code. You're going to get all this stuff. And so, if there's a way to get just this information, but I don't see it. There's no like raw button. Where's a raw? There we go. Okay. So yeah, that is probably. So let me see. Now you can't just feed this into here because it's not going to understand that is a. See, it can't read that because it's trying to get a local place on disk. So you're going to have to use URL lib. Let me see if you could. So I'm going to copy this down here. Right? And then do this. And then Control X. Yeah, so this particular method, no, it's easy to fix. So this eval method is actually what says, hey, what's on the page is actually Python code. Read in the Python code and turn it in to whatever it is. So that eval statement right there, it turns those squiggly brackets into a dictionary. So if we take that eval statement out, we're just going to get the raw text. So if we run that, yeah, we're going to get what you want. We get the data. See what I'm saying?
Okay, so we could take that and punch it in of the other line at the top. Having the file on our hard drive, we could just pull it directly from the server. Get that information there.
See if this works. So you can't read it line by line though. So you'd have to find a different way to do it. So it's not the lines that you're reading. Let's see if we could pull it off. So see this /n character? That /n character is in the new line character. So what we could do is create a new list that is every line in the table. So we could say do something like this. Line list is equal to lock.split. And then we want to split it based on carriage returns. Now let's print line list and see what happens. So it's not going to let us split based on that.
Can you join a statement like print lock location plus inside the parentheses plus line location plus line? Wouldn't that do something?
I'm trying to split it at the carriage returns. It's a Python split list /n. how do you split by split string carriage return? Split lines. Yep, that worked. So split lines is a Python. I mean, it works on strings, so you can split it at lines. So it looks for carriage returns. And
Like the B,
the B just tells me that it's not traditionally encoded text. So that's not a big deal. So if it doesn't have any character, that means that it's in ASCII format. If it has a U, it's in Unicode format. And I'm not really sure what B means, but it's just a different string type. But it doesn't really matter. We'll still be able to do it. So from here, what we would want to do is same thing that's right here. Feed it into a function. So actually, both of these statements now do almost the same thing. I'm just going to hashtag that out. So you see how this is saying city, state, country, Chapman, Alabama, United States. This one is also doing that, city, state, country, Chapman, Alabama, United States. But this is actually a list. So if we wanted to make these exactly the same, we would just go for line in line list and say print. Run this. We don't need this hashtag. Okay. So now we get each of those printed out. Now these actually have a carriage return at the end of each of these. I think we decided that strip works for that. I don't know for sure. Yep. Okay. So now these two statements, this statement and this code do the exact same thing. In fact, I'm going to Control X. Okay, so I have these in different cells. So this cell just contains the code that's going to get the address location. And then these two, this reads it from your local disk, and this reads it from online using URL open, but they both do the same thing in that they print out everything line by line yes, all the information out line by line. Okay. All right, so what's the next step? Well, the next step is to actually instead of printing out the name of the city, we want to print out a dictionary where the name of the city is the key and the value is the XY location. The key is this and the value is the XY location. So you have to modify either of these two lines. I don't really care. You modify this code or this code. Instead of printing out just the line, it's going to print out a dictionary. So it's going to look something like city name colon X colon well, I'll just put a fake address. Y. That's a fake location. Right? Bracket. Oh, yeah. I'm gonna hashtag that out. So right now, I'm just printing city name, but you're gonna actually have the city name there. So you're gonna change it so it doesn't say city name. It's gotta say the name of the city. And then it's not gonna put that here. So this is really, now at this point, this is really one line of code that you have to modify to get this to work. Or you could do the same thing here. You could put that same thing at that location. So you're just printing out, you're creating a dictionary, okay, with those values in there. Okay. All right. So what you need to do is think about what this function does. It takes a string as the input and returns back the output, which is a dictionary. So it takes this and returns this. You don't have to do it as one line of code. You could do it as 3 lines of code. Like if you want to call the function, get the result back, then build the dictionary, and then print the dictionary. You could do it like that. But you could do it all in one line of code. All right. All right, so I have to leave, but the second question is really, really easy once you know how to do it in GIS. So really you're going to run, well, let's think about it. You're going to run like 3 or 4 GIS operations. And so there'll be 4, you're going to import ArcPy, you're going to run 3 or 4 operations, and then you're done. So you just need to know which GIS operations to run, and then you can write the Python code to do it. So it'll just be good practice in running ArcGIS code. So we've got watersheds and census tracts. We've got watershed, census tracts, watershed, census tracts. So what I want you to do is find out how many people live in each of these watersheds. Okay? So what you're going to do is find out how much of each each census tract is in each watershed, and then find out how many people live in that portion of the census tract. So the way that you could do this will be on the video, but the way that you could do this is that you have these 2 data sets. I'm going to get rid of this so that it's not confusing because that won't be there in your data. So I'm deleting that field, that centroid X field. Okay, so I have these 2 data sets, and I have a bunch of census tracts, right? And I want to find out how many people live in each of these watersheds. So let's look at the census tract. Okay. This is the population right here. Okay. You got population, and that's the field that you want to mess with. And so to do this, we're going to we're just going to find out how many people live in there by doing a
Some operation?
yeah, but you got to do a union first. So you union the 2 data sets, and then you can dissolve based on the watershed layer. You can dissolve based on the hydrologic units, and then when you do the dissolve, sum based on the population. Does that make sense?
Right.
So you're going to do a union and then a dissolve. And you're going to dissolve based on the, here, I'll just do these really quickly. So then you just do this in ArcGIS. You just do this in Python. So if you do the union first, which we've already done, but we'll do the union. Watersheds, census tracts, and I run it, and I get my union, then I can do a dissolve. And then I say I want to take the watersheds union. I want to dissolve by HUC 8, but my statistics fields is I want the sum of the population, like that. And then when I run this, my output is going to have that HUC 8 sum, or sorry, the population sum.
What is okay?
HUC 8 is the label for the watershed.
Okay.
Yeah, sorry, that's probably. Anybody have any other good questions?
So that pump gate right there, that particular one has all of the, different watersheds in that list right there.
Which one?
Right there where it says pump gate under the union resolve, that one's after they're all already in one database. So like that 317006 is one, and then 7 is a different.
That's a different watershed.
Okay, gotcha.
These are each watersheds. And then the one that doesn't have anything, what's that mean, do you think? There's no HUC 8 value.
You can't move
It's
it.
probably water.
Well, some of it's water. Basically, it is where the census tracts existed and the watershed data set didn't exist. It's this area. So it's how many people live outside of all those watersheds. I guess if we'd done an intersect, you wouldn't have that there. So it might be better to do an intersect. The reason why I said union is probably because I was thinking that because we already did it. But if you did an intersect, you would get those areas. Now the only problem with doing an intersect is that the watersheds would not be shaped the same way they're shaped now. So the output, if the census tracts existed anywhere where the watersheds didn't, that part would get deleted. So I would actually do the union, and if you didn't want that little, these polygons, you could just run a select. So you could do that as part of your code if you wanted to. But anyway, you need to do a union and a dissolve to get the full credit for how many are. Now, last time I taught this course, I actually had you separate out all of the people by the proportion of their area. We did something similar in ArcGIS in my other class. If you want to do that, that's fine, but that's not required. So, but you do need to write a script that does the union or intersect, and then the dissolve, and get it to that point. Okay.
The second one, do you just want us to turn in turn it the same way we've been turning it in, or do you want us to give you something different?
I want a Python script. So you can copy and paste. If you ran it right in ArcGIS, you can copy and paste it into a notepad. Or if you ran it in Jupyter, you can turn in an interactive Python notebook. If you ran it in Python and IDLE, you can turn it as a .py file. Any of those will work. And then next week we're gonna take what we made and turn it into a toolbox. All right.
Okay, now, those things you talk about make it into Python script, this had nothing to do with Arc Pro or nothing like that, right? So that you suppose we just doing it in the Jupyter notebook, show you how we write it?
You can do it in Jupyter Notebook or you can do it in Python. In ArcGIS. You can do it either way, but I need the code.
Okay.
The code will be the same whether you do it in Jupyter Notebook or you do it right in ArcGIS. The only difference is that you could be calling the layers themselves in Python, but I'll understand that. In ArcGIS Pro. All right, I'm going to have to cut